Okay, so what we're talking about today is how to use synthetic divisions to find zeros of a polynomial. And so in case you have forgotten what a zero is, it's like when you have a quadratic and we solve it, and you would get two numbers, and that would tell you where we're crossing the x-axis. Well, in this case, we're dealing with polynomials that are greater, hold on, okay, that are greater than like an x squared. So like for instance, if I have an x cubed plus a 3x squared plus 4x plus 1. So remember, we talked about the number of times that a polynomial can cross the x-axis, and we said that the highest exponent represents up to the number of times that it can cross. So like here, 1, 2, 3. In other words, this graph could represent this polynomial. Now, I'm not saying it does, but I'm just saying it can, and every place it crosses the x-axis would be considered the solution or the roots or the x-intercepts. Okay, so, or the zeros. So these are all names for where our graph crosses the x-axis. So synthetic division, what it allows us to do, it allows us to find this. So it's actually when you're dividing a polynomial by a polynomial. And it says, how do I find the solutions given one root? Well, we're going to talk about that today. So here it says, do you remember how to use synthetic division? Okay, so we're going to use synthetic division to divide. Now, I just sent out a video to work this particular problem, but basically what you're going to do, we're dividing x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. So we're actually dividing these. So it's going to look something like this if I put it in a division problem. It's going to be x to the fourth minus 10x squared minus 2x plus 4 all over x plus 3. Okay, so as you can see, we can't do anything with this. You can't take like parts of a binomial and divide it into parts of a polynomial. The only way you can do this is by setting it up, and then we can actually use what is long division to work this out. So I know you guys remember long division from like elementary, and I'm not even going to go through this process because it's pretty complicated. So I'm going to go ahead and show you the shortcut for doing this. So if you'll look here, we're using synthetic division to divide. So this part right here is called the dividend. It is the number we're dividing into, and this part is the divisor. So what you do is you take that plus 3 of the divisor, change the sign, and we're going to put it off in a little box by itself, just like that. Next, you're going to take just the coefficients, okay, just the coefficients in your dividend. So because this is 1x fourth, we're going to take 1. Now, I forgot to mention also that you have to line your exponents in order, remember, like in standard form. So we have 4, 2, 1. But if you'll notice, we're missing an x to the cubed. We have to have that x to the cubed, and it's going to be 0x cubed. So that's why we're putting in a 0. So this 1 goes with x to the fourth, the 0 goes with x to the cubed, the negative 10x squared, negative 2 with the x, and then the 4. Next, you're going to draw a line underneath and bring that 1 down. And then we're going to multiply. Negative 3 times 1 is negative 3. 0 minus 3 is negative 3. Okay, so we're going to subtract that negative 3, and then it's going to be negative 3 times negative 3 is positive 9. Negative 10, positive 9 is negative 1. Negative 3 times negative 1 is positive 3. Negative 2, positive 3 is 1. And then finally, negative 3 times 1 is negative 3. Now, do you see this 1 at the end? If it would have been 0, then we could have said that x plus 3 is a factor of x to the fourth minus 10x squared minus 2x plus 4, and that negative 3 is actually one of the places where our graph would be crossing the x-axis. But it's not, it's 1, so therefore this is not going to be a factor of this polynomial. So this would actually be my answer. What we're going to do is replace all of the x's, but drop by 1 power. So x cubed, negative 3x squared, negative 1x plus 1, and this remainder just will simply go over the divisor, and that will be your solution. So factors versus roots. What are multiples together to get the polynomial? The things in the parentheses. So like for instance, remember when we would factor like an x squared, a quadratic, it would come out to be like x plus 2 times x plus 4. And then we would set them to equal 0 and then solve to get those. It's the same thing with a polynomial. So roots, when the x's values equal 0. So in other words, when we take these and set them to equal 0, that's when we get our zeros or solutions. So factors, and then set them to equal 0, roots, where we're crossing the x-axis. Okay, so I'm going to stop here, and then in the next video, we will continue on with the PowerPoint.